In this video, we'll talk about the exponent law of the quotient rule. So the quotient rule applies to expressions where we have division with powers. So for example, let's take a look at if I had 2 to the 15th power divided by 2 to the 7th power. Now there's a few ways I could look at this. I could think to myself, okay, well this is the same as if I have 15 2's up here. And I could keep going and going and going, but there'd be 2 times 2 times 2, 15 times, and that's going to keep going. Then likewise on the denominator here, I'd have 7 of them. So 2 times 2 times 2 times 2 times 2, so on and so forth, 7 of those. Now if I really think about it, multiplication and division naturally cancel each other out. So 7 of these 2's are going to cancel. That's going to happen 7 times. And if I think about that, if I cancel out 7 2's, on the denominator here we'll just have 1. That's all that will be left. And that would leave me with 8 2's after the cancellation. So that would leave me with 2 to the 8th power. Now, a shortcut here. So long as the bases are the same, that's something this one has very much similar or in line with product rule. This only works if the base number is the same. If the base number is the same and I'm dividing, I can subtract the exponents. This would be the same as 2 to the 15 minus 7, which results in 2 to the 8th. So let's take a look at an example here. In this case, I'll show you the shortcut first. So what we've got here, we have 3 to the 7th over 3 to the 5th. These numbers are the same. The base number is the same, so I can use a trick. So I'm thinking this should be the same as 3 to the 7 minus 5. Now it's very important that the order is taken into consideration. The top number always goes first, and then the bottom number. Okay? And then this will result in 3 squared. 3 to the 2nd power, also known as. Now, the other way you can think about it is if I write out 7 3's for the numerator. There's 7, and then we do the same thing for the denominator. 3 times 3 times 3 times 3 times 3. There's 5 of them. Okay? That one will cancel, 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 leaving me just 1's on all of these. So that leaves me with 2 3's, which is 3 squared. So, doesn't matter which way you think about it. However, I think the shortcut is going to be a simpler way of looking at it, especially if we're looking at more and more powers of 3. Now, another way where it can be helpful is if we're looking at variables. Variables make things a little bit more difficult, but the rules would still apply. So in this case, we can still apply it because we still have x as our base. Technically, that means it's the same number. So we're going to have x to the 9 minus 3, which would be x to the 6. Now, if I wrote out x to the 9th and canceled out 3 of them, that would make sense that there'd be 6 of them left. So, something worth noting. If I have something like this, if I have 4 squared, or 4 to the 3rd power divided by 5 squared, I have no trick for this because the bases are not the same. If those bases aren't the same, this trick is not going to work. It's just worth noting, this trick only works if the base is the same.